Welcome back to ye old Foundry into the Foundry office. This video I'm going to cover a Supermetal. And the Supermetal was invented about the same time as the Ford Motor Company came into existence, and about the same time the Wright brothers invented the airplane. Okay? About 1901, a person by the name of Robert Stanley, who was working for the International Nickel Company up in Canada, invented a new metal called Monel, spelled M-O-N-E-L. Now, he patented this in about 1903, I think, 1906. My notes are right here, so that's why you're looking at. You're seeing me glance over there. And when he put in his patent, at the time there was a law against naming elements or naming metals after people. I'm sure there was a reason. Maybe somebody would say, "Hey, that's my name, you can't use it," or something. No idea. Anyway, this person who was in charge, or who was the president of the International Nickel Company, went by the name of Ambrose Monel, M-O-N-E-L-L. He was, the person who invented Monel tried to name it after his president, and apparently this guy's a good guy because he was an entrepreneur, and he, always was a patron of a great many good things. So the inventor of Monel tried to name it after him, but he was told about the law. So what he did is he went and dropped one L off of Monel, Ambrose Monel's last name, and now it's M-O-N-E-L. Okay, now this was at a time when the International Nickel Company was mining. I think they had to have been mining. Why would they have mentioned this place? Anyway, there's a Sudbury mine up in Ontario. Was it Ontario? Yes, it is Ontario, and it's a natural two element mineral, already alloyed basically by nature, of a 50-50 mix of nickel and copper. And a sidebar, some of the stuff I've been watching with Trump going to the different places where they talked about how some of the good stuff he's done has made a real difference in people's lives. Well, there was a company up in I'll be darned if I can remember. It's either Minnesota or Wisconsin. I can't remember. Who was talking about how their mines were opening up, and that they had just discovered a large deposit of the same metal that, the nickel and copper alloy up there in that area. Okay, you just might start seeing more Monel being made if that's the case, but that's just a guess on my part. All right, back to the subject. Monel, very tough. Not very hard, but tough. Now, when you, as a metallurgist uses the word tough, they're talking about not just high tensile strength, but also a resistance to deformation. Okay? In other words, if you were to hit mild steel with a really hard hammer, it might make a dent in it a certain size. Well, you have the same shape and size piece of Monel, and it's not going to be making that much of a dent in there. Stainless steel, for that matter, is also described as tough. Okay, instead of just hard or just strong. Okay, when you say hard, you can call glass hard, but one strike at it with something and it breaks into little pieces. Just like cast iron coming straight out of the mold, if you dropped the let's say the ingates or the runner down on the floor, you just dropped it, that stuff is still very, very brittle coming straight out of the mold, and that'll break into little pieces, not tiny pieces, but it'll break into several pieces just hitting the floor from 2 feet up. Okay, so it's Monel is a very tough metal. Now, I have a lot of information written up here, and I'm going to turn to that in a minute. But first, I want to suggest strongly that you watch there's this one old movie that was made up, one of the industrial type movies that was made up, and the way it's written, it's almost like it was written by a company that was selling Monel. Okay, but despite that, its chief advantage for you to look at it is to be able to see all the things that they said could be made from Monel as an improvement over standard steel, aluminum, and other things that were being made at the time with steel and others. This was a vast improvement, in other words, over regular steel and aluminum, because of it being that much tougher. Now, it's a natural alloy up in Canada, but it's hard to mine. There's for instance, even in this day today, okay, nickel is mined in like 10 or 15 countries, but nickel is they're only making about 1.4 million tons of nickel in a year's time, as compared to about 800 million tons of steel that's being made in a year's time, and 10 million tons of copper that's being made in in a year's time today. So it's not that easy to make nickel. All right. Back in the turn of the last century, 1901, when this guy invented Monel, they knew about stainless steel, but apparently it was still in development. Okay, they were still having a hard time making it in such a way that it could be a very good material to use as a construction material, or just making pots and pans and the so forth. So Monel coming out and being fairly easy to make items out of became a huge super metal for the time. Okay, and for good reasons. Even today, it's an excellent metal to use certain things. But the problem is not just the expense of of manufacturing Monel or nickel. Okay, nickel is the problem, not so much Monel, but nickel is the problem to try and get a hold of it. Now, if I may have screwed up. Did I say Monel? Well, they only made 1.4 million tons of Monel. Let me correct that. That's wrong. That was nickel. They only made 1.4 million tons of nickel in a year's time. All those countries mining it. It's and I think it's what they have to do is they have to take the ore and electrically extract it or chemically extract it. I haven't gone into that section of it yet, because I probably would lose half of you if I tried to tell you how it was actually made into nickel that we could use as an alloying additive. Now, nickel is used in steels too. Nickel is used to add grain fineness, which would make the steel, the tensile strength of the steel, would up the tensile strength of the steel. But nickel also helps in corrosion resistance. Okay, the more you add, the less rusting you'll have. Okay, just like in the more material, stainless. It was just in my head. It was just there. Chromium. There's the word. The more chromium you add to steel, the more stainless steel you make. The better stainless steel you make. Okay. So let me go back to Monel before I get too far off. This movie which is called Monel Metal Dash As Modern as Tomorrow. They estimated in the title that it was made in the 1920s. Okay, and what it does, it tells you how much better most of the metals would be if it was made for the medical field. You know, all those operating tables made of metal. You know, they'd be easier to keep clean and keep antiseptic. They made a big deal out of telling everybody how well you could clean and make antiseptic all the devices that you would use, or all the equipment you would use for making food, either in the canning industry, or in the restaurant industry, or on board ships, where you would be, you know, you'd have a galley, but the metal might have been being attacked by all that salt air that's around. You know, salt air and steel, they're enemies. Okay, so they made a big deal about that. So please watch that movie. I will be putting the address to that movie on the well, in the description, where you see my description of this movie, rather the video. Okay, here's a, let me go down this a little bit. Let's see if I can turn away from this yet. I already told you about that. There's like in Monel's, you know, in stainless steels, you have a 100 series stainless steel, 200 series stainless steel, and I think they've gotten as high as a 500 series stainless steel. Each one of them become from 100 to 500, becoming less rust capable and less magnetic, to almost no rust showing up ever, and being anti-magnetic. No metal. I mean, you can't attach a magnet to it at all. Same thing happens with Monel. They have five 400 series Monel alloys, and you have one 500 series alloys that are being used today. Okay, the 400 series alloys, the first one, the 400 series alloy can be used for casting and forging and generally making things out of Monel. And the other alloys, or rather the other 400 series alloys, they just have something added to it that to solve a problem, as I read. The 500 series alloy, now what it has done, has added a bit of sulfur to the Monel, which, I mean, nickel is poisoned by sulfur. Okay, it's absolutely the worst thing you can put in a nickel alloy is sulfur. But what they had to do is they had to make it to where Monel was machinable. Now, if you're a machinist and you've got a chunk of Monel, you put it up in your lathe and you get it all ready to go, and you take your first cut across it, it cuts fine. It's easy. It makes nice chips and everything. But see what you've done when you went across it that one time, just below that one cut, you've work hardened that very surface that you're next going to cut, and it is terrible to try and machine after that. It is so hard you can barely machine it. Okay, so what they did to try and improve Monel, they put a small percentage of sulfur into the mix, so that throughout the mix it had sulfur inclusions, and allowed you as a machinist to cut, you know, to machine in whichever way you needed to machine that part out of Monel. Now, why would anybody want Monel? Well, it is every bit as strong as stainless steel. Stainless, it's corrosion resistance to not only running salt water, but almost all of the acids that are likely to come in contact with it, and therefore they use it in the chemical industry. And most alkalines that it would come in contact with it, totally not affected by acids, alkalines, and even running salt water. Okay, and running salt water usually is absolutely the worst you can have on salt. I mean on steel. And so they make a great deal trying to isolate the salt water from the steel by painting many layers of paint on ships to keep it, you know, isolated. All right. You know, they found that's, you know, while the stainless steel was very hard to work with, and it wasn't you know, worthwhile trying to make everything out of it. And even though that nickel was expensive to use, it was the best metal at the time that you could use to solve many problems. Now they found out that because it going through the salt water, they thought that they could make ships out of it. Now, prior to Mike telling you about this, if you have two metals and you have come in contact, you've got to choose your metals carefully, because sometimes you'll have metals that are so dissimilar in nature that I wish I could remember the phrase that they use. Anyway, the one metal, its atomic structure or atomic makeup will be such that it can draw easily the electrons and protons maybe from the other metal, and start breaking it down badly. It needs that extra atom, or rather not atom, but electron or proton. I'll say electron. It needs that other electron to finish up its makeup, and so draws it from the other metal. So dissimilar are these metals that the one feeds off the other one. Okay. Here's a major problem with Monel, as illustrated by this story. And there was a story in a magazine, or I'll say a magazine, where in August 12th, 1915, there was a yacht whose hull was being made nothing but Monel. Okay, now I don't know if that has any effect on any of the sea growths that can attach itself to a normal hull, you know, like barnacles and such, but they didn't mention anything about that. They made this yacht, and the inside of the ship was the regular steel beams that are nice and strong and support lots of stress out at sea. They attached the Monel to the steel beams. Now they didn't know this at the time, but the steel beams were giving up its atomic structure to the Monel. So the steel beams were so corroded that one time they got underway that the hull of the ship collapsed. Okay, and so that was a very bad story for that. So you don't use Monel and steel together, touching each other. Okay. I don't know if they knew about it back then, but you can counter that kind of corrosion with zinc plates. Zinc plates attached to steel will extend the length of the life of those steel plates and steel members on ships. In other words, the zinc will corrode first before the steel will. Now, I don't know if that would have been as effective as it is today with that combination of materials, but that's something they could have tried. That was a bad news item when that yacht went bad. It went to pieces in 6 weeks. Only 6 weeks after they made it. That's how fast the steel beams on the inside of the yacht corroded and broke down. Okay, now I'm going to take you over here and start pointing out some of the stuff about Monel. Okay, now we used Monel. I first came in contact, other than just reading about it, on my first ship, my first 2 ships. I first came in contact as a molder out in San Diego in 1977, 1978. Now, we worked with both Monel and stainless steel out there. And I think I remember we did make some pump bodies out of Monel. And I think mostly we made Monel impellers, okay, to try and replace the steel impellers that were being used at the time, or trying to replace the mag bronze and other bronze impellers that were being used, because even though the bronze impellers were, you know, corrosion resistant to seawater, they weren't nearly as resistant to corrosion as Monel. Okay, now easing on over here, maybe I should just stand up and do it, because I'll have a better angle of light. Okay, so here's Monel. Monel is a nickel copper alloy with some other stuff in it, just to make it a little bit stronger, or make it a little bit machinable. Okay, Monel's density is almost the same as brass and bronze. Okay, so it's fairly heavy as a metal. It's like, for instance, steel is only 0.28, or was it 0.27? Oh yeah, it was 0.27, and then stainless steel was 0.28 because of the chromium. Nickel's the range of elements in here for nickel is 60 to 67% nickel. Copper, 23 to 29% copper. Iron, 1.5 to 3.5%. Manganese, 0.5 to 1.5%. Silicon, 1.2 to 4.5%. Carbon, 0.1 to 0.3%. Sulfur, 0.03% max, because of the effect sulfur has on nickel. Okay, and then they have 0.5% max on aluminum. I don't recall reading why it is that they want to eliminate aluminum as much as they can into that. It might be that it just, you know, messes it up and the granules get a little more brittle. Okay, tensile strength for Monel between 65 and 125 psi. Not as strong as some steels, but stronger than a lot of steels. Okay, Brinell hardness, for those of you who test metals, is between 125 and 150. Now, to those of you who don't know about this, this is a way of testing how hard a material is, and therefore, you know, you go by this table, you get a certain amount of hardness, you'll have a certain amount of tensile strength. Okay, this is still used in most metallurgist or material handling testing laboratories. Now, Monel melts at 2460 degrees Fahrenheit. Okay, so if you're going to try and make this yourself, you're going to just go with the mindset that this stuff is like steel. It's going to be extremely hot, and it'll have a very bad effect on your molds sometimes. Because of its density, because of its heat, you'll have a lot of erosion in your molds. So if you can, you ram the molds as hard as you can, give it a lot of vents so that the gases and the moisture, the steam, can be vented away. But you ram it as hard as you can so that the erosion won't take place when you pour the Monel inside your molds. Okay, when you're trying to deoxidize the Monel, you take a ½ ounce per 100 pounds of magnesium, drill a hole in the stick. When the Monel is being melted down, you have that exposed to the flame so that you have zero moisture on this thing. Then once you're ready to try and pour this, you plunge it to the very bottom of the melt. Don't just ease it in, because that stuff will you know, it'll stay on top. I mean, you won't be able to get the effect of the deoxidizing churning that the magnesium will get when it suddenly expands down at the bottom of the heat. Okay, don't be scared of it. Just put it, as long as you don't have any material or any metal on it, or rather any moisture on it, you won't have a blow up. You won't have anything spitting back at you. It'll just do its job, maybe churn a little bit, and that's all the oxides and such will raise to the surface, and you'll be able to clean up your Monel and have you know, the best Monel you can ever get. Okay, but don't let that being magnesium scare you. It doesn't blow up on you once you touch the molten metal. You just shove it in there, stir it, take out your stick, and then start cleaning the molten metal. Okay, the best kind, they tell you the best kind of sand to use when pouring Monel is a synthetic sand, like green sand. Okay, silica sand will be 95 to 97%. Clay will be between 3 and 5%. You know, the more clay, the more it's going to the silica sand is going to be harder to dislodge. It'll be stronger. Okay, so you can start off with clay 5% and go to silica sand 95%. You'll have the strongest mixture for that, and then you have between 3 and 4% water to make it a molding material, molding sand. But here's the thing: even if you ram it real hard, even if you give it a lot of vents, and even if you you know, do everything you can to counteract the heat and the density of this material eroding your sand away, it may not work. What will work, and I have seen this myself, is that if you spray a mold wash where the, you know, inside the mold cavity and inside your runners and your ingates, well, and your splash basin. Okay, if you're able to get your hands on a ceramic style mold wash, that's even better yet, because it'll be less bothered by the high heat, it being you know, the ceramic style. But in the past, we would use a silica powder mold wash or a zircon based mold wash. Okay, so write that stuff down and look it up and see what the formula is for one of those two, and then choose whichever one you want to use. Okay, now, as I said before, sulfur poisons nickel. Okay, so you have a bunch of bad stuff in there. It won't be nearly as strong. It won't be nearly as resistant to corrosion if you have the nickel poisoned. All right, so if you're trying to make something like a pump body or an impeller or a pipe, you know, pipe part, a piece of a piping system for chemicals to go through, don't put any sulfur in it. If you have, I mean, sometimes sulfur is just a contaminant, and you'd have to try and get rid of that as best you can through other chemical means. Okay, let's say you've got the metal is ready to pour. Well, you pour rapidly as possible, because it will freeze up. It has a very narrow solidification range. So if you have a long distance that this stuff has got to go, then you'd better give it as many ingates all along the way as you possibly can. Center up that down sprue and pour it very, very quickly. Another bad thing about Monel is that it has a very high shrink rate. If you're a pattern maker and you're trying to make a pattern, you got to use 1/4 inch per foot of shrinkage. That's a lot. Okay, Shrinkage is great in the mold. You need to use risers. You can't afford to have a shrinkage in the middle of something that's going to have pressure in it. Okay, so wherever there's any possibility of shrinkage, put a riser there. If you want to, and you want to experiment, pour it without a riser. Find out where the shrinks are, and then put a riser in those spots. But it's better just to, I mean, with all the amount of effort you're going to have to put into to make the mold and the amount of effort you're going to have to put in to melt the metal, you may as well just put risers where they need to be, and then after it's done and over with, they get cut off, the excess metal gets ground off, and then you got your casting. Monel has high corrosion resistance to salt water, alkalines, and many acids. It retains, and now here's the most amazing part, and I never knew this before. Monel retains its strength and ductility in a range from liquid hydrogen, which is minus 423 degrees Fahrenheit, to up to 1,000 degrees Fahrenheit. Okay, so it remains as strong as just normal temperatures that you can walk through. But if in most cases, when you put a steel, even stainless steel, if you put a steel in liquid hydrogen to, for instance, make the item shrink so that you can put it in something else and then it expand in place, that stainless, if you drop it, it's likely to shatter because it no longer has the ductility that it needs, and after that part it becomes very brittle. Monel doesn't. It has very little change in its strength and ductility at that temperature, and there is no change up to 1,000 degrees exposure, for degrees Fahrenheit exposure, when it's heated up. Okay, so it's a super metal. It's something that, the only reason why we don't use it all the time nowadays is because of the expense of having to get the nickel, and the fact that the stainless steels have improved so much that any of the stuff that nickel was being used for, stainless steel is now being used for it. Okay, but if you want to try something that is tough as nails, will not be affected by corrosion, will not be affected by the cold or up to 1,000 degrees of the heat, try Monel. Okay, because it is hard to get nickel nowadays, you may not want to do it, but if you have the capability of getting your hands on both nickel and copper, just those two alone will make Monel. The other things that got put in there, they're just tweaking by metallurgists to solve problems or to improve some of the physical characteristics of the material. You can pour it, if you can pour it into a mold, you can make a casting out of it, and the same goes for Monel. Okay, I remember it was pretty tough grinding all the stuff off. Obviously you couldn't, there was no advantage for you to take a cutting torch to it to try and get excess stuff off of it. You usually wound up just using a cutoff wheel, one of those suicide saws, and taking it off that way, and then having the rest machined off. Okay, and that's the end of that story. I hope you enjoyed it. I hope this, maybe this, even for those of you who are inventors, maybe this material will solve what you're trying to make, any of the difficulties of the thing that you're trying to make. Okay, so to everybody that knows what this means, Liberty Call, and we'll see you later. As always, please make absolutely certain that I mean, especially with this stuff, as hot as that crap is, just like steel, stainless steel, you got to have everything on you that's going to keep you from getting burned up. That stuff, I mean, regular brass and bronze and aluminum, all that stuff, that's hot enough to kill you. Imagine that you're trying to work with stuff that's almost 3,000 degrees. Okay? That's hotter than that lava coming out of Kilauea. Much hotter. All right? So be very, very careful. Think nothing but safety first. And please pass the word about my videos. As yet, even though I've been doing this since last August, last year's August, and I'm still making some videos, I've not received one red cent from YouTube or anybody, and so you can assume that I'm not making these to make money. Okay? I'm doing this to pass down information to those of you who would like to maybe start a school, learn what you can, and pass the word on to other young. For instance, in America, a lot of this information has died out because it went to the grave with other molders. Before I start going to the grave, I'd like to have you know what I do, what I have done, and we have many other molders out there that are still alive and who are proud of what they were able to accomplish in the foundries in the Navy. We still have foundries out here in the United States, so take advantage of it. Okay, castings are much stronger than just things made out of sheet metal. I think I've said just about everything I need to say. So I'll see you later, and I hope everybody gives a thumbs up. And if you have any questions, as I always say, any questions that you have about whatever video that I put out, don't forget, whatever video that you watch, if you put something at the bottom, you make a comment at the bottom of that video, no matter how long ago it was made, I still receive the comment or the question. Okay, so it doesn't make any difference how old the video is. I'm almost always on the computer. It'll come up, and if I can't answer your questions off the top of my head, I'll look it up and give you what I found. Okay, I'll see you later. Goodbye. Now this portion of the video is going to be for a gentleman, that one of the subscribers, and what he wanted to do is he wanted to see in better detail some of the plaques that I've got or have made over the years. Now here's a close-up of the USS Thresher. Okay, here's the design that they went off of before the pattern makers made it for them. And I'm going to try and get close to this to see if you can read it. This is the explanation of what the Latin, theory, not theory, well, what they use in Latin on the mottos for the different commands is for. Okay, so there's that one. Now I'll go out to the hallway and get better, closer pictures of the other plaques. Okay, out in the hallway, here's this was the plaque that we had when I was over at the 32nd Street base in San Diego, California. Its command was DOTC FMAG PAC, and Development and Training Center, Fleet Maintenance Assistance Group. That was the command I was working in the Foundry at the Pacific Fleet out in San Diego, California. Now, before that, I was on the USS Piedmont 8017, a destroyer tender. Here is the plaque for the destroyer tender. Prior to that, I was on the USS Fulton AS-11. Here's a close-up of the Servitum Fidelitas, was the Latin phrase for them. Service, fidel, shoot. Faithful, okay, that was the word. Faithful service was their Latin phrase. Now, USS Sierra, AD-18, out of Charleston, South Carolina. Trying to get a little bit of light on it. You're a little bit farther away. Here's another Fulton that I had. At this right on this spot, I used to have a submarine diving, but it got knocked loose in a move. And there's another Sierra. Okay, that's all the plaques I have out here, and that's as close as I can get to you. Now, one thing I should point out: when you're making plaques, you see how tall these letters are and how straight. They're not going to have the angle on them that's going to allow you to take it out of the sand easy. This is the first clue that this was not a metal plaque. This is one of those plastic plaques that you pour the plastic, the two-part plastic, into a rubber mold. And once the plastic is solidified or cured, then all you got to do is peel the rubber mold away. The rubber mold eventually gets torn up enough to where you have to make more rubber molds. But this isn't a metal plaque. You can tell because of the excellent definition between the letters, and that wouldn't have been very good in a sand mold, because those tiny little letters, pressing sand in between them, and you try and wrap the pattern to try and take it out. All that stuff in between the letters would have just sheared right off, and you wouldn't have had those letters. To see the difference here, now this is plastic also, but this, at least you can see here how short the letters are, and how much easier it would be for us to take that out of sand and not leave a bunch of sand behind. Okay, there's the biggest difference. Heck, most of my plaques are plastic, I just realized. Anyway, and I don't know where my gosh darn Yosemite plaque went. So, I know I had one. So maybe I can find it someday, okay? So, to the gentleman who wanted to see the definition of the plaques, there you go. Now, one thing that I can show you that I made that I think is pretty neat. When we went to Barcelona the one time, I think it was on the Sierra, I walked around and I found a shop who made almost nothing but plaster. What do you call plaster? You know, stuff that you hang up on your walls, and you can paint them before you put them up there, and they're very, very inexpensive, I recall. And I made a few things. I made a kind of a Greek statue, and I'll show that to you here pretty soon. I made a Greek statue in the Foundry, and there was this real pretty rose that I thought would have been a great thing. It's just a wall ornament in this one shop, and as I recall on this one was something you could hang up, but it was made out of plastic. This one wasn't made out of plaster of Paris, okay? But this I made over in the furnace, or rather in the foundry on the USS Sierra. Now, as you can see, there's a lot of, it's very, very deep in here. But because of the way they made the plastic item, it came out of the molds very nicely. I had very little cleanup to have to do on them. And I made it solid in the back, as you can see that. Now this is, might have been aluminum bronze. It's got a little bit of dross on it, on here. Dross meaning, there was too much bumping around that the metal did, and so it absorbed some of the hydrogen and oxygen out of the atmosphere. It's almost like scrap on top of a steel heat, but it's inside your molds. If you ever have any of that inside of the wall cavity of a pump body, let's say, or a valve, it's going to leak by, okay? Anyway, so you see my anvil and hammer over there. I think it was about the same time I made that as I made this, and this came out nicely. Okay, so I hope you got enough detail, sir, and we'll see you next time.